good morning all of you. Today we are going to solve this physics AS level 9702 question. Let us try this question. First one, question number 12. The diagrams show two ways of hanging the same picture. Okay, so same picture. What is the meaning for that same picture? Both are having the same weight. So we know about the reaction, right? Reaction will be directly opposite. Reaction is a force, weight is also a force. So the force opposite to the weight will be reaction. Both are having the same weight. That is why R1 will be equal to R2. Both are having the same weight, right? That is why R1 is equal to R2. But we could not take the tension like that because the string length is somewhat differing. That is why angle will be differing. Definitely T1 will not be equal to T2. Let us find out whether from that conclusion itself we can select the answer. But we have to explain why the angle is differing, right? So to show that angle differing, that is the angle is differing because of that length, we know that. But because of that angle difference, how we are getting the two different tension, we are going to explain that one. Let us explain this one. First, I'm going to take this component, that is the cos component, that is the horizontal component of the T2 will be theta, and the horizontal component of that T1 will be theta dash. I'm taking like that, theta dash. So look at this. From the picture itself, we can clearly understand theta dash will be less than theta, right? Theta dash will be less than theta. So first case, what is the relationship between the R1 as well as R1 or weight? Both are same, right? So R1 as well as tension. So the relationship between the R1 and tension we can calculate by this way. Look at this. There are two force. There are two components acting vertically. This T1 component. Look at this. This T1 component as well as this T1 component. Vertical component can be taken as sine theta. So 2T1 sine theta dash. Because vertical component, there are two vertical component acts opposite to the reaction. That is why I have taken like that. Like that R2 will be equal to 2T2 and sine theta, right? So we know that theta dash will be smaller than theta. So theta dash is smaller. That is why sine 0 will be 0, sine 90 will be 1. So when you are increasing the data, the value gets increased. So sine theta will be higher in value than sine theta dash. Then calculate T1. T1 will be equal to R1 to sine theta dash. Sine theta dash value is small. That is why T1 gets increased because the denominator value is small, right? That is why T1 gets increased. Here T2 will be equal to R2 divided by 2 sine theta. Sine theta value gets increased because theta value gets increased, right? That is why T2 will get decreased. So finally, we have concluded that T1 will be high because of the denominator lower value and T2 will be low because of the denominator higher value. That's all. And let us do one more question. Here, look at this. An object shaped as hemisphere rests with its flat surface on the table. The object has radius r and the density rho. The volume of the sphere is 4 by 3 pi r cube. Which average pressure does the object exert on the table? Okay, let us check what that pressure formula will be. What is that? Force per area. Force will be mass into gravity per area. We don't know the gravity, right? Sorry, we don't know the mass. We know only the volume of that hemisphere. So how we can calculate that volume of the sphere? Volume of the sphere will be 4 by 3 pi r cube. Hemisphere will be just 1 by 2. That is volume of hemisphere. Hemisphere will be 1 by 2 into 4 by 3 pi r cube. So volume we have calculated. We know the density. Density is equal to mass per volume. So mass will be equal to volume into rho. Volume already we know 2 by 3 pi r cube into rho. Mass we have calculated. I am going to substitute that mass here. 2 by 3 pi r cube rho into g divided by area of that sphere will be. Why I am taking that area of the sphere? If you are cutting that sphere, you will get to the sphere as a circle. That is, you will get one surface as a circle. That surface will be in the circle form, right? So that is why the surface area of that is the area of the circle will be pi r squared. So pi r squared I am going to substitute here. R squared r cube, 1 r will be remaining, 2 pi 3 r into rho into g, right? Sorry, 2 pi 3 r into rho into g. This is very, very easy, right? This one is the right answer. And then question number 14. So a probe is used to monitor the quality of water in the sea. The probe is suspended by the vertical string which is attached to the sphere. The stationary sphere floats in equilibrium on the surface area as shown. The sphere has a weight of 5 Newton. Okay, the probe and the string have combined weight of 2 Newton. Okay, the density of water they have given, the upthrust acting on the probe and the, okay, so they are saying that the upthrust will be negligible here. Okay, not necessary to calculate that volume of the string. What is the volume of the sphere below the surface of the sea? So they are asking the volume here. So how we can calculate that volume of the sphere? Volume of the sphere that immersed will be equal to the volume of the water displaced, right? But we don't know how much volume gets that is how much volume gets immersed. But we know the volume of that sphere will be equal to volume of that water displaced, right? So how we can calculate the mass of the, that is density of water will be equal to, density of water will be equal to mass of water divided by volume of water. So volume of water we can calculate mass of water divided by density of water. Density of water they have given, but mass of water they didn't give, right? So how much water has been displaced by that sphere? That will be equal to the buoyancy that we can calculate by using the buoyancy force. So buoyancy force, what is that? Buoyancy force will be equal and opposite to the force exerted by that sphere and the string. We didn't give any external pressure. So that is external force. Only force acting on the sphere and the string will be 5 plus 2. That is because of that gravity. Mass and gravity, mg. So that force is enough to take, because we are not giving any external force. So buoyancy force will be equal and opposite to the force exerted by that sphere and the string because of that gravity. So it will be 7 Newton. It's not 7g, 7 Newton, right? 7 Newton. This is the force that has been exerted. We know that mass of that sphere and the string, mass of sphere and the string, overall mass, total mass, I am going to take that as a total mass into gravity will be 7 Newton. So total mass will be equal to 7 by g. We know that mass of that is total mass that can displace the same amount of water from that sea. That is mass of total, that is mass total, that is mass of sphere and the string will be equal to the mass of water displaced. So from that, how we can calculate here? Mass of total can be taken as mass of water. So density of water we need only volume of the water displaced. So volume of the water will be equal to mass of water, that is 7 by g, and the density of water is 1.03 into 10 to the power 3. So 7 by 9.8 into 10, 1.03 into 10 to the power 3. So if you are taking that one, you will get the value 6.93 into 10 to the power minus 4. So how we have calculated that volume of the water displaced will be equal to mass of water by density of that water. How we can calculate that mass of water displaced? That will be equal to the force by gravity. So the total force will be 7, and acceleration due to gravity will be 9.8. After substituting this, you will get the answer. Thank you.